In this video, we're going to evaluate the integral of ln of x over x squared. I'm going to work it out using integration by parts, and then I'm going to set it up as a U-substitution for you. You can do it that way. You'll still have to use integration by parts, so it'll be a little bit longer, but I'm just going to give you the setup for that one. So here's the formula we're going to use for integration by parts. Integral of u dv will equal to the product of u and v minus the integral of v du. So I'm going to let u equal to ln of x, and I'm going to find my du. Take the derivative of both sides. Derivative of ln of x is 1 over x dx. And my dv, I'm going to pick that as 1 over x squared. That'll be my dv. And I'm going to write 1 over x squared as x to the negative 2. Then we take the integral on the left with respect to u will give me a v. On the right with respect to x, add 1 to the negative 2 will be negative 1. And then divide the coefficient by a negative 1 will give me a negative. And this should be a dx here. And now we're set to plug it into this formula here. So u multiplies v here. So I'll put dv in front. Minus x to the negative 1 times the u. Give me ln of x. And then it's minus in the formula here. And that's going to be the integral of v, which is a minus x to the negative 1, times the du. So du is 1 over x dx. So this is equal to then, and I'm going to write this as a minus ln of x. That's the first part of the answer. Still going to be there. Got the negative, and instead of x to the negative 1, I'm going to put it over x. And here I have a double negative here. So this will make a plus here. And then it's the integral of x to the negative 1 here. So this is 1 over x and 1 over x. So it'll be a minus 1 over x squared. So let's make that x to the negative 2. And we take this one off here. So we already multiply these two here. That's positive. And then here is just 1 over x, and 1 over x is 1 over x squared, which can be written as x to the negative 2. Still got the dx here. So again, this is minus ln of x over x. And the integral here, we add 1 to the negative 2, we get negative 1. We divide, so that'll give you a minus out here. It'll be x to the negative 1. I can write that as 1 over x. And then it's plus the constant of integration. So that's the first method. Final answer for this one. Clear this then. So here's the method. Next method is the standard U-substitution. So the first one was integration by parts. And you'll see that's the shorter way to do it. But just in case you want to see it this way, this is the U-substitution. So I'm going to let u equal to ln of x. Then du is equal to 1 over x dx. This implies then if I multiply through by x, that dx is equal to x du. Okay, so I just multiply here, both sides by x, puts the x over there with the du. And then I start with the integral here. Integral of ln of x over x squared dx. And then in the next step here, I replace the dx by x du here. Okay. And then in the next step, I went ahead and canceled one of these. So one here and one here. So that left me with x in the bottom. Remember, I want just u, because I'm using a u substitution. So I want the integral in terms of only u, not x. And then of course the ln of x, that's u. So we placed it here. So now everything is set there. Okay, everything is set. Except, well, the x. So from this equation right here, or I should say this one right here, this one here, this base is z here, ln of e. Natural log is base e. So this tells me by definition of log that x has to equal to, well, I have it right here, e to the u. So getting back to this one here now, I have an x there, I don't want an x, so we should just place it by e to the u. There it is. And I just took it to the numerator and became e to the negative u. And then here, we just used integration by parts. So it's the same formula over here. You can do it the same way. Pick your U, your dV, and integrate as usual, and you're going to get this right here. This is actually e to the minus u here, okay? So I replaced it ahead of time there. So this was the minus u, but u is ln of x, so I got that there, okay? And then here, same thing for this one. U is ln of x, and it's got a minus there. And you got it here. Well, let's see how it works here. Minus, and then u is ln of x, and then it's e to the minus u, and u is ln of x. We in the next one we got minus e. And of course that was a u. It already has ln of x, so I'll take it from there. Plus c. For this one here, I take this negative here and bring it there. That's x to the minus 1. Because this space is e and this space is e. That just gives me x to the negative 1, which is 1 over x. That's how I got this one over here. And the same thing for this one. Got a minus, and then the negative comes right there. So it becomes e natural log of x to the negative 1, and because this is space e and this is space e here, that gives me 1 over x, and then you got the minus right there. So that's the solution for this one. Minus the natural log of x over x, minus 1 over x, plus the constant of integration. Thanks for watching. We'll see you next time.